Hello. How's everybody doing? I know it's getting late in the day, getting close to booze time, dinner time, whatever you call it. It's 2012, and it's PHP, ZendCon 2012. Hopefully you guys have been soaking up the rest of the Zend Framework 2 talks. It's a complete rewrite, including this component right here, database. So there's definitely lots of things to look at and explore and code to talk about, and especially if you're into Zend Framework 2 development, building apps on top of it. So like I was saying, it's 2012. We're still using relational databases. Sometimes it's considered legacy. I know that there's a lot of cool talks on document databases, and ZendDb, if you're wondering, is not about document databases. So if that's what you're here for, sorry. We're still stuck in relational land. But I'm going to jump in. I got basically 2 sections. I got slides that go over the architecture of ZendDb, and then the back half is more code-centric, jumping into code, exploring the API, all the various things you can do with it. So for those who are not familiar with who I am, I'm Ralph Schindler. I've been on the framework team for 4 going on 5 years now. I've been working at Zend for 5 years. Before that, I was a contributor, just like the other 400 people that are contributing to Zend Framework now. While I was contributing as a contributor, I was at 3Com, in a smaller company that 3Com purchased called Tipping Point. It was a security company. I was building internet apps. Zend Framework was the best choice at the time, so I started working with it there, and that's how I got involved. At this point, I've been involved with PHP for 13 years. I guess that makes me a veteran or old or something. Currently, I come from New Orleans. Before that, I was in Austin for 5 years. So that's a little bit about me. So just one brief slide about Zend Framework 2. It's important to know what the philosophy is, just so that you kind of understand the philosophy moving into the components. It is the next generation of Zend Framework. For Zend Framework 2, we decided to embrace PHP 5.3 and in some places 5.4. You will find some traits here and there. In embracing 5.3, we also started looking at the landscape, how people were programming. Some of the aspects that came about were AOP, specifically the event-driven nature of Zend Framework. So that's a little bit more, that's a different style of programming than you used to see before, where there was a lot of inheritance. So now you've got cross-cutting concerns that are addressed in the same way that we compose classes together. In that vein, though, we are attempting to be more solid. If you're not familiar with solid principles, there's a Wikipedia article on that. It's a good read. The takeaway from that is there's definitely more interfaces in Zend Framework 2, specifically in ZendDb. We try to practice dependency injection much more than we ever have in the past. That's not to be confused with understanding dependency injection containers, but just know that when there are dependencies and there is composition that needs to happen, we're talking about injecting those dependencies into one another. Overall, Zend Framework 2 is definitely more agile. We actually do use Agile Zen for burning down on various tasks and things that we're developing, and that's exposed on our website. There is no more CLA, so if that was got in your way for contributing previously, that shouldn't be an issue anymore. We also recently, we've been having the code on GitHub. We actually just moved away from Jira, so issues can be reported to GitHub as well. We're really embracing the whole social coding, minimizing the barrier to entry to get you guys, contributors, consumers to give back. So about a year ago, we did ZendDb the first pass, and basically what that meant was we converted it to namespaces. And while we converted it to namespaces, we also took the exception standards and we implemented those. But for all intents and purposes, it was a namespacified ZendDb from Zend Framework 1. The API was roughly exactly the same. We kind of left it alone up until about March of this year, and that's when the major rewrite happened. So in short, the requirements that I gathered, and the requirements that I gathered came mostly from looking at the framework version 1 issue tracker, seeing where all the pain points were, and just coming to conferences and having people complain to me about why they couldn't do certain things. So I built a short list of requirements. They basically were a more clear and concise API. So in the solid way of thinking, that's the single responsibility aspect. Open for extension. You should be able to take the interfaces that are in ZendDb and extend those things, inject them back in, and change the way it fundamentally works. Again, practice dependency injection. We are definitely favoring composition over inheritance. And more specifically, we're not attempting to solve model domain problems. How many of you guys, by show of hands, are using Doctrine? I've used it in a number of projects. It is not Doctrine. It doesn't attempt to solve the repository, mapper, entity, domain model sort of stuff. And side note, I know Brett, there is two talks on domain-driven design if you're into utilizing relational databases and building out domain-driven design style models. Definitely visit those talks. So what does it mean in practice? With the exception of one class, you won't see statics anywhere. So if you were familiar with ZendDb table in version 1, there won't be a set default adapter static method that you can pull and get that static adapter from anymore. And while that's not there, we do have, if you've paid attention to Evan's tutorials and whatnot, there is the service manager. So that's generally available throughout the framework, and that's where you're supposed to get your adapters from. There's lots of simple interfaces. So previously, in the interfaces that we did have, there was probably 10 to 12 methods. We've tried to simplify that and get those down as much as possible because the fewer methods that are in an interface, the easier it is for you to extend those, create an object, and inject it back in. ZendDb adapter, which is we're going to get into in a second, is the main object, the main namespace that you should be concerned with because it is the dependency for all the other things that we're building. For example, the table gateway, the SQL component, the metadata component, and maybe in the future an active record component. I don't know. There's very few abstract classes because we're favoring interfaces. There's definitely no final keywords. Like I said, this framework in general is open to extension. One of the more famous blog posts out there was by Patty Brady, and he basically said that people were able to subclass Zend Framework to death, and I've seen it. It's definitely true. I've seen some extensions that you have never thought were possible, but that's what people do, and that's what we allow you to do. We don't make anything private. Everything is protected. All the API are database-centric, not model-centric, so hammering on that fact that we're not building a modeling layer. We talk about rows, columns, tables, schemas, as opposed to entities, and verbiage of that sort. So in the slides, we're going to talk about the architecture a little bit, and all of this stuff resides under the ZendDb namespace. If you go to the GitHub account for ZF2, you can just switch over to ZendDb, you can browse the code, and it'll roughly be broken down like this: adapter, ResultSet, SQL, TableGateway, RowGateway, metadata. So jumping right in, the first, like I said, kind of ZendDb adapter is the place where we start because it ultimately ends up being the consumer for everything else we write. ZendDb adapter is the top level namespace, and the class that's primarily implemented here is ZendDb adapter. I call this the kernel because basically it gives you access to all the various pieces that make up the adapter, and the adapter becomes the dependency for other things. So I think we're going to be able to read these slides. This is a little bit smaller font, but once I get into the code samples, I can blow this up. Basically, the API for the adapter looks like this. There's a couple of constants. There's the constructor, driver, platform, query, current schema, a couple of interesting, convenient APIs. But that's less important here. We'll understand what the various pieces that make it up when we move to this slide. There's two primary parts. There's the driver aspect, and then there's the platform aspect. The driver is effectively the thing that connects the userland ZendDb adapter to the database on the back end. So we know those things as extensions in PHP. So for example, PDO, MySQLi, IBM DB2, the Oracle extension. We call those, we wrap those things and we call them drivers. It is responsible for the reporting capabilities of the extension, and it coordinates all of those various tasks in 3 subsections. They're really objects. Everything related to connections, everything related to statements, and everything related to getting results back. Sometimes the PHP extensions don't have 1 or 2 of the other classes implemented in the same way as another extension, so this is our attempt to normalize that workflow across all of the drivers. So when you talk about the connection interface, there's just a couple of important tasks. It needs to be able to connect. You need to be able to tell if it is connected to a database. You want to be able to disconnect. Transaction, committing, rolling back. The one that's used the most in non-prepared statements is this one right here called execute. And the last one down here is a little, when you look at the landscape of databases, it can be a little bit goofy in that sometimes it's easy to get the last ID from the last insert statement, and sometimes, in some databases, you actually have to go consult a sequence table or some kind of special function that'll give you that value. So it tries to do as best as possible to get that value for you. Moving on from the connection object, there's the statement object. This is the interface for statements. The resource, anytime you see get resource on any of these connection, statement, or results, it's basically either going to try to return to you the underlying thing like the PDO statement or the PDO connection or the MySQLi resource when you say get resource. So it could be any of those things depending on the extension that you're connecting with. So for statements, when we talk about statements, we're generally talking about prepared statements. So the workflow for a prepared statement is preparing. You want to be able to determine from this object if something's already been prepared. And once it has been prepared, you want to be able to execute it. So those are the 4 main methods that this interface attempts to expose. Finally, after you're done preparing a statement or executing SQL through the connection directly, you'll end up with a result object. And sometimes this wraps an internal resource. Sometimes it's really just wrapping an array of information that came back from the driver. It all depends. But ultimately, you're talking about asking the result to buffer or determining whether or not it is buffered. And again, when you look across all of the various database platforms out there, they handle this sort of thing differently. The reason why you might want to buffer something is that you might have a database adapter that's a forward-moving cursor. And by saying, hey, go buffer this, you're saying, I know what the costs are, just pull all of these variables back into PHP. Even if it's 20 or 40 megs of information, I'm okay with that. Pull it back into PHP. So we give you that option in the interface. We didn't give you that option in Zend Framework 1. So what happened was a lot of times in Zend Framework 1, we buffered for you automatically, and if you had a really, really large result set, there was the possibility that you could hit your PHP memory limit. So here up front, we allow you to default to the extension and force buffering if you need to. You can get the affected rows. You can get the last generated value. If that was a primary key auto increment or if it was a sequence, whatever, we're going to try and do that as best as possible in the most common sense way possible. And finally, get field count. So while you can get the number of rows sometimes, that's another issue we'll get into later. You should always generally be able to say, well, of this result set, is there a field count if it was a select, and how many of those fields were returned? So that's the driver. That's half of the adapter right there. The platform side's far simpler. It's just one interface. The platform is responsible for knowing how to quote vendor-specific stuff. So the reason why this is broke out is there's 3, maybe 4, technically, MySQL extensions out there. And for every driver, we didn't want to go re-implement the quoting mechanisms. So we created one platform object. It's called MySQL, for MySQL naturally. And it does the quoting for MySQL in the MySQL specific way, which basically means by default, you do it using the backticks as opposed to the ANSI quotes, so on and so forth. So there's a couple of variety of different methods here. There's get quote identifier. So there's things in a SQL statement, there's identifiers and there's values. Both of those have a very specific way in which they're quoted. And this interface spells it out. There's quote identifier chain. you'd have to look at the API to understand it a little bit better. That's kind of used more on the back end when you have an array of identifiers you want to quote. Quote value symbol, which basically will return for this particular platform what the symbol is for quoting. Quote value list, naturally that's going to be dealing with arrays. Get identifier separator. You wouldn't think about it. Like if you're familiar with most of the common modern database systems, they're generally using a dot. That's not always the case. I know DB2 doesn't use a dot, it uses a slash. So that's why this is abstracted out here. And then quote identifier and fragment is kind of a useful utility method for basically saying, here are some optional safe words. Don't quote these, but quote everything else. And that's useful for when you basically want to construct some SQL and you want to say foo as bar. Naturally, I don't want to quote as, but I want to quote foo and bar. So it allows that kind of workflow. So creating an adapter in the solid way, in the way in which we inject everything and have all these objects and all this specialization and separation of concerns, this is generally what it looks like to create an adapter. There's 3 objects that make up the driver portion, and then there's also the platform portion. And as you can see, this is a big, huge pain in the ass. That's just the nature of dependency injection, separation of concerns. There is an easier way. What we do in the constructor of the adapter is basically if you provide an array of information for the first parameter, we're going to look at that information and say, can we make some really educated decisions about what you're trying to construct here? And it gets really simple. For SQLite, if you pass in driver PDO SQLite and database path to SQLite file, it'll construct all of those objects for you, and it'll give you back an adapter. So you get the best of both worlds. If you really wanted to override something, if you wanted to extend it and inject it, you can. But if you just want to get going, the easy and configuration-driven way, where this information came from a config file, you can do that as well. Now, this is more of a documentation thing. I'll touch on it briefly. But basically, the idea behind the connection abstraction was that if somewhere on the web you saw a key or a set of strings that talked about connecting to a database, we wanted to support that. So if you were on the MySQL documentation page and they called the database DB name, or if you were on the SQL Server documentation and they called it whatever, PWD for password, we tried to support those as best as possible. So if you take an array of information like UID and PWD for SQL Server and pass it in, we're going to know about that, and we're going to allow you to create a connection based on that bit of information. All of this stuff, like I said, is documented on the pages for ZendDb. But basically what it allows you to do is it's a little bit more flexible when it comes down to taking the information and constructing a valid connection-worthy adapter. So like I said, there was a couple of methods in the adapter that I would consider convenience. This is one of those. We have a method called getHelpers. It is tedious to, and let me back up. If you want to use ZendDb for the purposes of building an abstraction, for building a module in Zend Framework 2 that plays nice with all the various databases, what you're going to want to do is make sure that you're quoting things in the vendor-specific way. And the only way you can do that is by using the facilities of ZendDb adapter. So in order to do that, we've created some helpers, and this is one of those, and it embraces closures, because that's a nice 5.3 feature. Basically, we say get helpers. We tell it which helpers we want. In this case, it's the function get quote identifier and another function called format parameter name. And we get those, and I put them in small, short variables called QI and FP. And when I want to go create a vendor-specific string that has everything quoted correctly, I can call these functions. So artist is a quote identifier, name, and QI. And then finally, the format parameters, name and ID, those are going to get passed in, and it's actually going to ask the driver, hey, how do you go about formatting these things? In some cases, it's :name. In other cases, it might be a question mark. It just all depends on the driver that you're using. So for this particular example, using the ANSI standard, so to speak, you're going to get identifiers that are quoted by double quotes, and this is very much a PDO thing where it's going to say :name. But again, it's going to do it in a way that is the absolute correct way for that adapter that you got those functions from. ZendDb ResultSet is a way of us that we have attempted to normalize iterating result sets. Sometimes databases return those things to you from an array. Sometimes they give you a statement that you iterate. Sometimes it gives you a result object. We take those things and then we wrap them in a result set. Now you have a common API for iterating whatever the result set was that came from whatever vendor platform. Generally speaking, a result set's a collection of rows. Those rows, depending on the result set's options, can either be presented back to you as objects or arrays. There is a default concrete implementation of result set that is going to be used by default across the board, but there are other ones that, for example, if you saw Rob Allen's talk, he talked a little bit about something called a hydrator, which is an object that basically looks at other objects and says, how do you want these values injected? Are they public properties? Are they setter methods? How do you want to do it? So there is a hydrating result set, and it implements the result set interface, and that's also in the framework. If any of you guys saw my tutorial, or mine and Matthew's, I talked about specifically the prototype pattern. This is one of the more interesting patterns that I think I use a lot in ZendDb, primarily because we focus on the interfaces, and we don't want to go creating objects with the same signature in the constructor. So I think I'll be able to show you why that's the case when we get to the code-centric stuff at the end. So what does the result set look like? It's generally, the concrete implementation looks like this. By default, out of the box, it's going to give you an array object. If you're familiar with the SPL array object, we do that because it's the most flexible. In the way that it is used by default, you can access it as an array, or you can access it as an object to get the information out. You can switch the return type to just array if you want, and you'll get an array of information back from the result set as you iterate it. More on that, again, later. Moving back just real quick, that's the result set. It implements the abstract result set, which is this here. And again, you're going to see things like the iterator interface implemented. There's a method called buffer, which it's going to try and do some smart buffering based off of the result object that's in there. Valid, rewind, count to array. It's going to do all of these various things in the best possible way it can, depending on what you actually provided it, be it a result set from a database or even just an array of information. Simply put, the result set interface looks like this. It's got two methods, and then it extends countable and traversable. In PHP, traversable, it actually doesn't, it's more of a marker interface. There's two specific implementations, or two super interfaces that implement traversable. That's iterator and iterator aggregate. So at this point, to implement result set interface, it's completely up to you. It can be an iterator. It can be an iterator aggregate. It just has to say, what do I do on initialization when I get a data source, and what is the field count? See, you can see that we intentionally leave the interfaces as small as possible to not get in your way when you're ready to start extending these things. So that's the adapter. This section right here is probably the most interesting section for most people, because once you start jumping in, the thing that you want to do is, chances are you already have a database, you want to start querying from it. We've implemented SQL abstraction inside of the ZendDbSql interface. Currently, the ZendDbSql deals only with data manipulation language, so basically that's select, insert, update, delete. It operates, for all these objects that I'm going to talk about, they operate in two modes. You can either prepare statements, which I always suggest you do, for performance reasons, which was ultimately the reason why they created statement preparation in the first place. But alternatively, you can use these objects to generate the straight up code with the values inside of the statement. So there's statement preparation, which that's the workflow that you'll see. You create an object, you create a statement object, and then you say to the select object, hey, can you go prepare this statement with this adapter and this statement? And then that statement object that you provided it is now prepared. Alternatively, if you just wanted to generate the string, and this is definitely still useful when you want to test your SQL or your select statements, you can say select, get the string. By default, you don't have to provide it anything. It's going to try and do it in an ANSI-specific way with the ANSI-specific quoting. But if you give it the platform object, for example, the MySQL platform object, it'll use the MySQL-specific stuff, like the backtick quoting. So moving on, one of the goals about these SQL objects is that we wanted to make sure that they were serializable, that they were clonable. These are workflows that you'll probably find that you've created a select object that has a couple of the fields inserted into it that you want to use continually. You can either save that to your session, or you can pass that around and clone it to other objects to utilize. That's all completely fine and dandy. Basically, since we're injecting the things that we need at preparation time or generation of SQL time, these objects are extremely lightweight. At this point, it's currently planned for 2.1. It might get kicked to 2.2, but at some point we are going to create a DDL, and basically what that means is that in addition to select, update, insert, delete, we are going to have things like create table, alter table, and you'll have an API for that again, it will try to do as best as possible, create statements that are specific to the platform that your adapter is bound to. So in the meantime, I'm going to show you some API here. This is going to be very brief. The insert, the update, and delete, I don't find those very interesting. I find the select stuff more interesting because it's just such an expansive topic area. But I'm going to show you the insert, update, and delete. It basically looks like this. You create an insert object, and all of these objects promote a Fluent API. And essentially, you can take that insert object and say, in a very SQL verbiage-specific way, insert into what, foo in this case, values, which is generally what you'll see in your insert statement, and then I gave it an array of information. For the second parameter there, I gave it an expression object. This is synonymous with Zend Db expression in version 1.0, or the whole 1.x series. And this will effectively produce, when you say insert get SQL string, that thing at the bottom, which basically is insert into foo, bar, boo, bam, values, baz, now, which is not quoted because it's an expression, and the SQL keyword null. So it tries to do things as best as, it tries to take what you gave it and say, what do you really mean by this, and how am I going to create it in a way that, in this case, is ANSI SQL compatible, it could be MySQL compatible, so on and so forth. Update, very similar. Update actually builds on kind of insert in a way that you have the same capabilities as insert, but you're able to provide a where. So you see that in the API here. I created an update object. I also created a where object. You don't necessarily have to do that, but I just wanted to show that aspect off. Update, table, foo, set something, which is generally an array of information, and then where, and I passed in the where object. This semantic right here is going to be exactly the same as the select semantics for where when we look at those in a second. So again, same thing with delete. Delete takes a where. This time I didn't use a where object because I didn't feel it was all that complex. The simplest way of using where is to pass in an array like ID equals 5 or ID 5, which effectively means delete from foo where ID is equal to 5. So like I said, the more interesting aspect, at least to me, is the capabilities of selecting stuff. The select object is where you start building queries. It deals with stuff like columns, joins, where, offset, limit. Offset and limit was included in beta 4, kind of late in the game when it came to developing this, mainly because offset and limit are things that are the least common across all of the platforms. They all do it a little bit different. And you can go Google or Wikipedia windowing routines for database, and you'll see that across the board, no one has a really sane solution. In fact, I think it was last year that SQL Server finally got a sane offset and limit, and they modeled their database, in such a way that I guess they didn't think people wanted to window through results easily. I don't know. Like I said, the API for all this is very fluent. Some might call it linkish if you're coming from the .NET world. I like fluent APIs, especially when you're talking about meta languages like this object is promoting for SQL, because the object and the syntax you're using looks a lot like the statement that you're actually creating. So visually, it's easy to track what's going on. So in a very basic sense, this is like insert, update, and delete. This is select. Select from foo, columns, array, barb as. We'll produce a statement that looks like select foo.bar as bar, foo.baz as baz from foo. And as you can see, select is a little bit, select is going to be the bigger component of all these, and it's trying to do things in a very explicit way. So when I told it the table foo, it's going to utilize that identifier for all the columns that, as a prefix for all the columns, so that just in case you're doing a join later, it knows the difference between, the database knows the difference. There's no ambiguity between the columns that you're trying to select. I touched on this earlier, but ZendDbSql expression is the takeoff of ZendDb expression in ZF1. This code is probably going to look a little bit small, but this is how complex it could get. Expression allows you to do some interesting things. Like I said earlier, there's identifiers and values, and they both need to be quoted differently. And in cases where you're parameterizing the query, the value doesn't actually get injected into the SQL. It gets put into a container and then passed to the database later. So all throughout ZendDbSql, or ZendDbSql, we're tracking what are values and what are identifiers, and we're keeping them separate the whole time. And this is so that we can do that smart replacement of the question mark or the colon name parameter in the statement for the driver later. Building off of the expression, these are all things, and the more technical term for the things inside of a where are predicates. If you're looking through the source code, you'll see a predicate directory, and there's a whole bunch of things in there. Getting more technical, the where is really a predicate object. They're all nested, so there is a tree of objects in there. And when we're ready to build a statement, we just traverse the tree in a very tree-like way, depth first, visiting everything so that we create the proper SQL that you tried to express through the API. There's reading material there. You can go look at where for SQL. All of these various predicates are based off of truth values, so you'll see equal to, not equal to, things of that nature. In addition to the select objects being fluent, the where object is also fluent. I have an interesting SQL for this in the code sample, but basically there's keywords like nest and unnest, and that's effectively your parameters. And if you wanted to build something that had a lot of parameters in it, it overloads the get operator, and it does something like, it allows you to do something like this, where nest, like, name, Ralph, unnest. Not interesting there, but it's definitely more interesting when you start combining 4 and 5 different predicates. So briefly, what does the where look like? Well, the where object is actually empty, as I said earlier. It extends predicate, but predicate looks like this. These are all just basic operations that are very handy. And if you wanted to know what was going on, you could go to the source code, go to the predicate object, and each of these are actually producing objects and injecting those into the tree. But this is the convenience API. So you'll see things like nest, unnest, equal to, not equal to, less than, greater than, like, literal. Literal being the thing where you actually want to pass literally that value. Is null, is not null. In, which takes an array, and you basically can say this value in this set, and it'll produce that SQL for you. And like I said, that last object, that last method down there is get. That's how it makes it all this possible. Those values up top in the doc block for property are the ones that you can utilize on the Fluent API to make those complex queries. those complex where statements. So again, I will get into some interesting code samples for that. So the supported predicates between expressions in things that I've covered already. Again, there's going to be more in the demo if time permits. That's the URL down there into the GitHub account to browse the code to kind of see what's going on. What's interesting to note is that in all these code samples, I was just sending the select object to the get string command, and what that's going to do is basically provide you with an ANSI compatible string. That's not actually SQL abstraction. That's doing your SQL in an ANSI compatible way. But when I say SQL abstraction, I really mean when you told me limit and offset, how did the database expect to do this? And to get that level of abstraction, you actually have to use one other object in conjunction with these in your normal workflow. And again, this is only if your goal is not to produce, queries that are bound to multiple or shareable code that can run on multiple different platforms, then this is not necessarily important to you. But if that is the goal, to create modules that can work on SQL Server just as they do in MySQL, this is a workflow that you're going to want to try and remember to do every time. Again, this is a workflow that we do automatically inside of bigger components like TableGateway and RowGateway. So that object is up front in the ZendDbSql namespace. It's the SQL object. It's very simple. You instantiate it with the adapter. And from this main SQL adapter, there, again, are some convenience methods in here. For example, calling select will produce a select object for you. Calling insert will produce an insert object for you. Optionally, to keep that fluent style syntax, you can provide that table name in here, and it'll automatically inject it into the insert object for you. And just like the other objects, you're going to have two methods, the two modes of preparing an abstract, SQL abstracted statement or string. Those are going to be prepare statement for a SQL object and get SQL string for SQL object. Kind of long methods, but again, we do this all in one place in most of the components that we write. So getting back to that problem with SQL Server, it's a pretty simple API, but it has some significant ramifications. This statement looked pretty innocuous. Select equals select, new select, select from foo, columns, bar baz, order bar, limit 5, offset 10. And in all the code samples, this is pretty simple. It's going to produce that SQL. Well, that works on the majority of vendor platforms out there, except for, and this is not including SQL Server Denali, this is including everything lower than that. That's not going to work on SQL Server. So what do we produce? When we say SQL, create a new SQL, and then take that same select object from above and pass it to get SQL string for SQL object, we're actually going to generate this. Many of you that have done SQL Server stuff, you're going to notice this kind of pattern of taking result sets and then wrapping them in a subselect and then flipping things forward and backward. That's what we do for you. That's where the SQL abstraction portion of all this really starts to shine. So this is the algorithm we used. When you say limit 5, offset 10, this is what's going to happen on SQL Server. Again, things of this nature, the abstraction at this level, of the SQL abstraction at this level, it only picks up in really strange cases. Another strange case, incidentally, is MySQL doesn't like offset and limit quoted. I don't know why. Everybody else allows you to do it, but they don't. So we use the same SQL abstraction sort of facilities to not quote those when they come out for MySQL. So building on the SQL, these are the, when I talked in my tutorial about doing domain-driven design very briefly, the ones that I like to utilize the most in a data mapper is TableGateway, not so much RowGateway, but definitely TableGateway. This is a component that consumes ZendDb adapter and ZendDbSql to produce a TableGateway object. And real briefly, by show of hands, how many people are used to or have seen TableGateway objects or use them in their common workflows for databases? Okay, so you guys have mostly seen the API for this. If you need, there's the reading material right there. That's a one paragraph. It actually breaks out into a whole chapter in a book. That particular book, Patterns of Enterprise Architecture. And in brief, it's an object that acts like a gateway to a database table. One instance handles all the rows in the gateway, in the table rather. The interface is generally going to look like this, and in the Java samples that you see in that book, this is basically what the interface looks like. You have a select, it takes a where, insert, update, and delete. And this object represents a table in the database. So the implementations that you get from that interface in ZendDb are going to be ZendDb table abstract table gateway and ZendDb table gateway table gateway. If you're noticing a pattern here, the most common implementation of something that we have is going to be named the same as the namespace it's in. So that's going to be the first place you look. It's kind of like an index file in a directory for a web server. If you're looking for the table gateway, you go to that namespace, and then the first object that you're going to see in there is table gateway. It's probably the one you want to use. Same thing with SQL, same thing with adapter. So what does the table gateway look like? More interestingly, it doesn't do anything except construct an actual object. We've implemented table gateway and an abstract table gateway. The abstract leaves effectively, it marks the object as abstract and allows you to construct that object in a way that you think is the most sensible. And then what we have done is we've created table gateway, which is a concrete implementation that adds the constructor in. So the constructor generally looks like this. It's going to take a string for the table name. It's going to take in an adapter. And at that point, you're done. You have an object that can interact with the table, insert, update, delete, so on and so forth. There are some things here that make it a little bit more interesting. For example, I'm not going to go into the features in depth here, but there is an API for adding in features that allow you to basically, through proxying of objects, you can inject functionality. And this is another compositional pattern. But that's further documented, and that's probably a little bit outside of the scope of this talk. Prototypes, the prototype of the result set, by default, this object will create one for you, but you can always inject it. And again, that SQL object right there is where all of the sub-objects, the select, insert, update, and delete come from. So we pass that into the table gateway, and now it has all the facilities it needs to do the job of doing table gateway type stuff. What does the abstract table gateway look like? It implements the table gateway interface, like I said, and then adds on to that. So you'll see things like initialize, which is going to do some initialization code. It's going to allow you to get the table, get the adapter, get all those dependencies that were wired in, and it expects to have. You can get the columns, the feature set. Again, I won't go into that. But then for every other method, you can actually pass in a select object, insert object, delete, and update. And there's a dual API for that. So you'll see the insert, which is covered by the interface, but then you'll also see insert with, update with, delete with, so on and so forth, which is going to allow you basically to pass in actual objects as opposed to fragments of statements or arrays where you would normally expect to pass those in at. It does provide some magic methods. The best way to explore those, I find, is if you have an IDE, go pull up a table object and then just start typing and it'll show you what's available. The RowGateway, again, if you've used TableGateway, you're probably familiar with RowGateway. The synonymous object here is going to be ZendDb table row from Zend Framework 1. And effectively, each object of a RowGateway represents a physical row in the database. So both TableGateway and RowGateway are very one-to-one mapping to physical persistence level things. The interface is very simple. It's got save, it's got delete. Because those are the things that you do with a row. You save them and delete them. They probably came from somewhere else, but this interface is not concerned with how you get it. It's only concerned with what you can do once you have it. An actual implementation looks more like this. This is the RowGateway implementation, and then where you see inherited, everything below that is going to be the abstract RowGateway implementation taken from there. And it's very similar to TableGateway. It acts a lot like an array object. So you'll see offset set, offset exist. Those allow you to use the array notation on this object. And then you'll also see get set, is set, unset that allows you to use the object notation for all the properties on this object. There's an API for determining whether or not this row already exists in the database. And then exchange array, again, is a method that mimics what you would normally see inside of an array object. So briefly, I want to talk about ZendDb metadata. Again, this is another component inside of the ZendDb namespace. And in brief, this component is capable of interrogating a database schema for information. Generally speaking, there's a couple different ways you can go through a database and get information out of it. You might be familiar with the information schema on most databases. But then in Zend Framework 1, we also had some facilities for calling describe on a database, or extensions sometimes have their own methods for getting metadata out of the database. So the metadata interface basically is a vendor-neutral way of getting that information out, which was not an easy task. And this is the one reason why right here. When you look at this interface, you're going to see a lot of, I would say, cruft in there. A lot of times you're going to see schema and database. These concepts of a schema and a database are, of all the concepts that you'll see in databases, are the most inconsistent from vendor to vendor. Some people call a database a schema. Some people call a schema I can't remember what Oracle calls it. But basically, and then sometimes they might swap them. A database in the hierarchy is below a schema, and so on and so forth. So this is the route that we've chosen. When you look at the hierarchy, you call something a database. It contains schemas. Schemas contain tables. Tables contain rows, or columns rather, in the hierarchical view here. So when you see objects that came out of ZendDb metadata, or you've instantiated from the ZendDb metadata namespace, you'll be able to do these sorts of things on them. You'll be able to ask it for table names, ask it for view names, column names, constraints, and triggers. That pretty much gets you all the information that you could possibly need at this point in time. I haven't seen a single issue or feature request come in, so at that point, I'm kind of waiting to see how people end up using it before starting to blow up the interface here with more features. So I think at this point I got about, I guess, 13 minutes or so, and I wanted to jump into code. I think. Actually, let me go back to the slides, because this way I can show you where the code is. The repository I'm going to be working with is located here, GitHub, Ralph Schindler, ZendDb-examples. There's about 30 of them in there for now, and this is effectively when someone comes to me and says, can it do this, and I have to say no, I take a use case from them, I put it in here, and then I go make sure it works in ZendDb. That way I have a couple of things. I have a working example. I'm also going to go produce unit tests, which are generally not the best things to learn from, but they do a very good job of ensuring things actually work. And then I produce the code to make it happen as well. And then sometimes we get to the documentation if it's a large enough feature. I also mentioned that I did the patterns tutorial yesterday. There's actually an example application in this repository, GitHub Ralph Schindler patterns tutorial app. This was an attempt to build an application based off a SQLite database that allowed you to go in there and say, I've got this database. Now I'm going to start constructing objects that can best model my application. So when I say model, I'm definitely talking about the domain-driven design stuff, repositories, mappers, entities, the more abstract concepts like aggregates and aggregate roots, so on and so forth. So this is really, in the master branch, there's an application, and it's got all the models stripped out, and then there's another branch in the GitHub repository that has my solution to that sort of problem. There's no really right solution. You really have to look at a project's list of guidelines, and you have to really understand the problem area to develop objects that suit that domain model. But like I said, that's my solution. Someone else that came up behind me might do it completely differently. Okay, so I want to explore first select. So one of the things I told you guys was that with select, the number of things you can do with select is really expansive. It's a very it's a very feature-rich language for getting rows of information out of databases. So I want to go through a few here and just kind of talk over them, so to speak. So in its very basic form, there is select, take an object, you say from foo. Very simply, in an ANSI sort of way, it produces this. Now, this is an interesting object here. This is also in the ZendDb SQL namespace. It's called table identifier. What this allows us to do here is that when you say select from, if I wanted to qualify that specific select statement as a table in a particular database or schema, I use the table identifier to do that. So by saying table identifier foo bar, I'm saying that in the database or schema bar, there is a table called foo, and I want to select all from that thing. So it's going to produce this kind of statement right here. Generally speaking, if you just give it a string, it's going to assume that your SQL is running against a very particular schema or database, and it's going to issue SQL that does that generally would be database or schema less. So someone might say, hey, I want to add an alias. You can do that. You basically say array, and you use the array notation with the array arrow notation where there's a key and a value. In this case, the key becomes the alias, and then the value becomes the actual table. So if I wanted to say, for every reference of foo, call it f, this is how you'd go about doing that. I can do that, again, with table identifiers. It looks generally like that. Foo, table identifier foo, it does the same thing as it did before. I could go ahead and I could add in a database or a schema to that, and it would expand that SQL out to produce that with the schema in the actual string. Adding columns is actually pretty interesting as well. And again, hammering on the fact that this is a very fluent API. It mimics the thing that it's going to be outputting. So select from foo, columns, array, bar, and baz. It's very explicit, as I said earlier, about putting the table name on the front end of that. So foo.bar as bar, foo.baz as baz, from foo. So getting a little bit, more interesting, taking that same example, I want to make, in this case, I want to alias a column. You can do that as well. Again, using the array key arrow value notation. So bar is baz, and it'll produce that. You can mix these notations, and generally speaking, you might want to put these on separate, multiple lines for readability, I guess. But I'm doing it here in one line just to kind of save space. Basically, I'm mixing the key value here, and I'm adding just a value. And as you can see, it's doing as you would expect it to do down here. Expressions, as I said, those were Zend Framework 1 ZendDb EXPR objects. And this basically is a way of saying, don't quote this. So when I said columns bar as count, that's going to allow you to say select count from some column as the identifier bar. Interestingly, and I wanted to prove that this was definitely the case, when you say count as bar, it's not going to quote this bar right here. So this is something you have to be cognizant of. Everything that you put inside of that expression object in the first parameter, it's going to take it as a literal. It's just going to inject it. It's not going to touch it in any way, shape, or form. So that might lead you to ask, so if I wanted to create an expression that does have some stuff in it, how do I go about doing that? So now we get down to this example where you have a select object from, just as we were before, from foo columns with this array, and then the first one is going to be an expression object. Well, the API for the expression object is actually quite interesting. So the first one is just as it was in Zend Framework 1, it takes in a string. It's not going to quote that. And it's interesting, you should know that when we talk about placeholders in Zend Framework 2, specifically with the expression object, the placeholder is going to be a question mark. Regardless of what the adapter thinks the driver wants, you use the question mark for expressions. Later on down the line, when it goes to process this query, it's going to take every question mark, then it's going to ask the driver, hey, how do you go about quoting this? If it's a colon name or it's a or if it is an actual question mark, or in some databases it's a slash and a number, like I think that's Postgres, the way Postgres goes about quoting things. What is it? Dollar and a number? Okay, so it'll do that at the last possible minute. So when you're dealing with expressions, use the question mark. So here what we've done is we've said count something plus something as something, and I would need to provide those values, the PHP values being a string, a number, and then another identifier. But now it has no context. So I got to give the expression object a little bit of context. So backing up a little bit here, in that array of stuff, I want to tell it, hey, the first one was an identifier, the second one was a value, the third one was an identifier. So now it knows when it needs to go generate something. It'll produce, I think these are a little bit backwards, but it'll produce count, some column, question mark, which will be replaced later as bar. And it'll contain, interestingly, something called a parameter array, and it'll have this value in it. And it'll use that parameter value when it goes to do the prepared statement later on. So I'm going to kind of cruise through these a little bit so I can get to the other code samples. Joins, there's the join API. Like I said, go into an IDE and just start typing, and all this stuff will code complete for you. Basically, it does the on clause, the value that, or the condition that you want to join upon, columns, and then the last parameter is going to be the type of join you want to do. So just cruising through these. Getting down to the where statements, this is where things really do start to get interesting. If I pass in x equals 5, it's going to substitute that in as where x equals 5. It's just going to assume that you meant there was an expression there. Where returning parameters, if I send in an array with an expression that has a question mark in it, it will do the substitution for you. So when you're producing SQL statements, it'll say x equals 5, and this is it's single quotes, which is the default ANSI quoting mechanism. But it'll also have an array internally where array equals 1 for this kind of workflow right here. It does grouping. It takes either an array of information, or you can call it multiple times. Either way, it's going to produce the same output. Groups can have expressions. There's also the having API, which you generally don't, I don't see it a tremendous amount, but it is as important as grouping. There's also ordering. So ordering has loosely some keywords, ASC and DSC, just like the SQL standard. So when you say C1, C2 from order, you're going to get ascending, which is the SQL default. It always assumes that you're ascending first, and then it'll only do descending if you ask it to. And to specify the ordering, you pass those in as key values. So C1 descending, C2 ascending, and it'll produce this statement. Again, you can chain these things, so you can say order this, order that. It keeps track of these things, and it's producing a stateful select object as it goes along. More interestingly, we chose the verbiage limit offset because I think MySQL kind of stuck their flag in the ground 10 years ago when or 15 years ago when they created their limit offset implementation, their windowing implementation. And I think for PHP, it's the verbiage that everybody agrees upon and understands the best. So when you say select from limit 5, you're going to get limit 5. Limit offset, you're going to get this. And again, thinking back to that SQL Server example, it'll do that windowing routine if it has to for the SQL abstraction. Complex joins. Now, I also remember early on I said that there was a platform and there was a method called quote identify in fragments. That's basically what's going on right here. Given this bit of information, and because I know you're giving it to me in the form of the condition for the join, I'm going to attempt to quote that thing. Generally speaking, the majority of the time, it is correct. It'll go through and say, hey, here are some values, or here are some identifiers. I'm going to go quote those as best I can and produce a statement for you. When that ceases to work, that's when you want to start getting into the expression. And when you have the expression there, you can be in complete control over how things are quoted. So more stuff. We do subselects now. you create a select object from bar where, we're getting into the Fluent API right here, where, like, why, foo. And we're going to use that as the basis for a subselect. So we're going to pass it into the from portion of a select, and we're going to give that the identifier x. So that'll produce something that looks a lot like this. More intricate where predicate is not null. When you say where is not null, this is actually the workflow it's going through. It's going to go in and create this object and pass that in as the third portion of the where array, that tree that I was talking about. So if you were to var dump or you were to step through SQL, the building of a SQL, you'll see a tree in there, and you can go click through and see, okay, here's the where object or the predicate container and all the various predicates that are in that tree. I think I'm going to try and wrap up in a, what time does this go through? Is it 5 o'clock? All right. This is the last one, select predicate operator. This is actually what's going on, like I said, under the hood. This is just more complex. It's utilizing joins. So outside of that, this is the repository, the GitHub Ralph Schindler. There's the patterns tutorial app, which I mentioned is the modeling thing. There's the ZendDb examples. And basically, this is where I integration test all of the ZendDb stuff. Just to give you one or two examples from here. If you clone this repository, you'll see stuff like this, and at the very end, you'll see assert example works. When I go to run this, and again, this works out of the box. There's actually, for some reason, oh, here it is, ZendDb far. So if you clone this repository, you can just run these examples. They will run. And they will run off of a SQLite database that you set up. Just read the README. It'll go through the steps. But when you go to run these things, it'll basically do this. It'll run through and say, hey, it works. This one's just creating a select statement. Number 6, I found that one interesting. That's doing the table gateway. So table gateway select ID equals 2. When you run that, it's going to return a row. And I'm checking to make sure the name is equal to this band name, Linkin Park. It inserts stuff. So table gateway, insert a little array. All the way down to more complex stuff like this. And where's the other cool one I wanted to show? Oh, yes, this one. So the Fluent API, you're able to produce things like this. Where equals to, or equal to, or nest, like, name, so on and so forth, nesting, unnesting, all these various things. And they ultimately end up producing this SQL. So maybe you want that API, maybe you don't. I don't know. I think it's cool. I think it's very linkish. And I have a lot of fun when I write stuff like that. So hopefully you like that API as well. To wrap this up real briefly, 2.1's coming out in a couple of weeks. In there is going to be DB2 adapter, Oracle adapter. 2.1 or 2.2, depending on the time, is going to be DDL generation. 2.2 is kind of up in the air. So basically, if you feel like there's stuff missing, let us know. I'm going to wrap this up. I'll take questions all week long. You can come up to me anytime. I'll probably be wearing this shirt or one of the other cool shirts that are out there. Come talk to me. Clone the repositories. Play with them. Again, my name is Ralph Schindler. That's me on Twitter. That's the URL to Zend Framework ZF2. Actually, I need to update that. It's actually just framework.zend.com. I'm in beta mode still. GitHub, Zend Framework is where the repositories are, and mine is GitHub Ralph Schindler. So I don't want to keep you guys much longer, but if you want to have a one-on-one conversation about any of this stuff, come find me. So thank you guys.